So this problem is from the last contest, and the problem has many solutions. And the ideal solution, we cannot use DP because it has 4 directions, and I cannot use I cannot also use a DFS directly, DFS and BFS, and it has a exponential level time complexity is it will TLE, and this is TLE backtracking solution. And for this one, and also I can use a digilast algorithm. For this algorithm, the basic idea is every time, and I use PQ and get the current minimum absolute difference. And for this difference, and I can to check the 4 direction, and for direction for each if any direction point can be verified, and we can add this PQ, and also to for this step it means it's update extend the status, and if the current status I use additional 2-dimensional array to record the current difference matrix, and if current different matrix more than the I got the current max, and I need to update it, and then continue to for this PQ, use PQ data structure help me. And this is this problem has another solution. Use binary search, and also use greedy. And for the binary search, and for every problem, when you thinking have it is difficult to directly consider, and I can consider use I suppose you consider it for the binary search. Binary search means ensure left and right boundary, and then get the middle value, and for the middle value, and to use the BFI check whether it has that valid path has valid path has maximum absolute difference is include this middle, and if include this middle, and I can use this effort as a candidate and let the boundary to select. Otherwise, and I will make the left boundary to go forward. So that's a binary search. And another solution is grading. Grid is to use with in grid solution, it use unifound to uni and compile the current minimum path. And if I find that the path can go the endpoint, that is our solution. So the unifound, the grid solution is from this one, from start point, and every time we go the minimum absolute difference path. For this one, we can go from 1 to go to 2, to also go to next 2. This is 0, and also to go to 2. For this path, it has a current minimum absolute difference during the weighted, and I will to uniform every 2 points. And from this 2 start, and the next minimum difference jump to from 1 to 3, 1 to 3, 1 to 3. Then this means start another new path. For this new path, 1 to 3, 3 to 5, 5 to 3, and 3 also go to 5. And I will continue to go this current minimum absolute difference for this path, and during the traverse, and I will unit and to also to when the unit is finished, and I will check the first point and end point whether has the same the parent node. If it has a parent node, then I can find the path. So right now I will implement the first solution, binary search. Binary search, my template is like this, and I will set the left right boundary. The boundary can be more range, large range, and for this solution, and the critical point is to implement use a DFS or BFS to implement this check solution, and to use I will use the BFS to check the current effort is validation. I will use is okay, and the parameter is this one. Will intimate add, and for BFS I will use the Q. The Q I will save the XY coordinate operation for point operation. Q will push the first node, start point, and the BFS will be go the forward direction. Go direction, and I will get the current X front first. The XY coordinate front second, and right now pop this current operation, and I will go the forward direction. New point will be changed. Current plus the DR. First DR, first key. Key first, key second. I will to check the validation chart condition, valid condition X. I will check the column size, and I will get the column size, row size, and column size. I will get this one. If not, match the column. CY. And also it's not visited. I will define visited. Auto visited equals also is vector. Is two-dimension vector. And initial value is false. Initial value is false. It's n, and visited equals 0. 0 is true. Visited. X CY. And another judgment condition is if current the difference more than the input effort is less than the effort. That means the current path can also go is more than effort hit. Yes, and the ABS difference. Current ABS X and Y, the next point and the current point, and if the maximum absolute difference for the maximum, that means the maximum is the minimum. I need to ensure it's a less than. If it's more than, that is not invalid. And if less than and the invalid QU will push. Visited one save. Finally, I will return the visited. The last element equals true. The last is m plus 1, n minus 1. And I will also define a direction. Will set a four direction. Minus 1 for direction array. For direction array. Right now I got the finish and I will try run it. Auto vector is not int. Push dot push Q. This is Q. I will try. So from this one, I will try the more test case. Let's submit. So this code is finished, and so we can say the binary search has a more efficiency. And for binary search and for the checking function, and I use the DFS. Similarly, I can also use right now I use BFS, and similarly I can use a DFS to implement this function. And the key point is check the current effort. If the current effort more than the A, that is not invalidation. And if invalid, it match the requirement. And I will to continue to visit every point. And finally I will to check the endpoints, whether the endpoint visited is true. If it's true, that means I found a matched path. This path has a maximum absolute difference is less than this effort. So right now I finished the binary search solution. And the next video, I will continue to talk about the graded solution. And the graded solution use a unit need to combine the unified. And I will to explain the detail for the next video. Thanks for checking my video.